All right. So now let us continue with example 7. So example 7, example 8, and example 9, they are about a dielectric. What happens when you insert dielectric and with and without battery connected? So a parallel plate capacitor has a plate of area 280 now cm square. Again, this is not in SI unit. The first things that you need to do is to change it into meter square. So remember, 1 cm square, it is equals to 1 times 10 to the power of negative, not 2, but 4 meters square. Okay, because you need to square the C as well when you want to calculate the value, when you want to do a unit conversion. So they are separated by a distance. Now, distance is the distance between plate. Okay, so this is your small letter D. Just now you have the A. And then the unit D is equals to 0.55 mm. If you look at unit, once again, this is not in SI unit. So you need to change everything into SI unit. So the first crucial part in this subtopic is to make sure everything should be in SI unit. So the plates, they are in vacuum. Now, why is it important to know whether it is vacuum or not? If it is vacuum, then you can get the epsilon naught from the list of constant. If it is not vacuum, it means that you're looking at the permittivity of dielectric material. So that one you have to search from the questions. It must be mentioned in the question, right? So if it is not vacuum, okay, and you need the value, it will be given. You don't have to memorize any of those dielectric constant value, permittivity of dielectric. But if it says vacuum, then you have to look for the values in the list of constant. Okay, so epsilon naught, it is equals to 8.85 times 10 to the power of negative 12, right? So if the potentials is a 20.1 volt, is the supply to the capacitor, calculate the capacitance of the capacitor. Now, you want to calculate the capacitance. Obviously, if you look at these questions, you are given A, you are given D, you are given epsilon. Straight away, you can calculate the C by using epsilon naught A over D. So this question is just to test whether you know how to do a unit conversions or not. Okay, so you have to be extra careful with all these units. So if you plug in the values, okay, and then you should obtain 4.51 times 10 to the power of negative 10 farad. Okay, 4.51 times 10 to the power of negative 10 farad. So that is the answer for questions A. Questions B. Now you want to calculate the amounts of charge on each plate. So you have a C right here. Questions give you V already. It's a supply to the capacitor. So now it means supply voltage is same as your voltage across capacitor. So you have Q equals to CV. Oops, my C. Q equals to CV. You plug in the value. Eventually, you will obtain Q equals to 9.07 times 10 to the power of negative 9 coulomb. Okay. And then the last one, the electric field strength was produced. So when it comes to this chapter 2, capacitor, it still involves electric field between two parallel plates. Okay, because your capacitor looks like this. This is your capacitor. So in between the capacitor, when you have a positive plate and the negative plate, in between them, there are electric field. Okay, there are electric field in between them. So this electric field, you have to calculate it by using uniform electric field equation, where E is equals to V over D. So rearrange the equations. V equals to ED, which is equals to, you want to calculate E, oops. Okay, you want to calculate E, so equation should be E equals to V over D, which is equals to 3.66 times 10 to the power of 4 Vm negative 1. Okay, so this is the answer. Okay, this is the answer. Well, this one you don't need it. So E equals to V over D equals to 3.66 times 10 to the power 4 volt per meter, because you are looking at parallel plates, okay, or we say uniform electric field. Okay, this part is uniform electric field. Electric field. So basically, chapter 1 and chapter 2, they have a bit of a relationship. Okay, they are a bit related to each other. So example 7 is just a very short and simple questions where you learn how to calculate the capacitance on the capacitor based on the dimensions given, the physical structures, the values of the physical structure, and then you calculate the amounts of charge, and the last one you determine the electric field between the plate, which is the uniform electric field. So next we're going to look at questions 8. Question 6 is a bit interesting now because you want to see what happens with and without battery. All right. So questions 8, example 8, a circular. So now you see, you don't always have a square or rectangle shape of a plate. You can have a circular plate. So now you have a circular parallel plate capacitor with radius of 1.2 cm. This is the radius of 1.2 cm. It's connected to a 6-volt battery. After the capacitor is fully charged, battery is disconnected. When we say battery is disconnected, when we have this statement, what does it mean? This statement itself, it tells us Q is constant. This is the keywords that you need to look for in your questions. Battery is disconnected. You remove the battery means that you remove the charge supplier. So no more charge can be added into the circuit because now you remove the supplier already. So battery is disconnected without the loss of any of the charge on the plate. If the separation between the plate is a 2.5 mm and the medium once again is air. Okay, when it comes to air or vacuum, that it means that you need to have epsilon naught. Okay, you are looking at permittivity of a free space. Calculate the initial amounts of charge on each plate. Now, if you want to calculate charge, of course, you need the C. Okay, you are given V. You have V equals to 6 volt, but you don't have C. But what we do know right now is that you have C equals to epsilon naught A over D. Okay, epsilon naught A over D. So I'm going to calculate the A now. Given radius 1.2 cm. Okay, so area of a circular plate. Now you have a circle. Circle A is equals to pi r squared. Okay, so it is equals to pi. Remember to change it into meter. So 1.2 times 10 to the power negative 2. Therefore, A is equals to 4.52 times 10 to the power negative 4 meter squared. Okay, meter squared. So now that you have it, and then you have the separations between the plate, and you know that epsilon is epsilon naught. So plug everything into the equations, you should obtain C equals to this one. This one you calculate it. Okay, I don't have the value with me right now. So you calculate the value, see how many farad. So from here, okay, from here you can then determine the Q. So Q equals to CV. Okay, plug the values into the equations. You should obtain 9.6 times 10 to the power of negative 12 coulomb. Okay, 9.6 times 10 to the power of negative 12 coulomb. So that is the final answer. All right, that is the final answer. Okay, now what happened next? If their separation is increased to 8 mm after battery disconnected, calculate the final amounts of charge on each plate. This is actually a very tricky question. Why? Now, because it tells you battery is disconnected already. So it doesn't matter what you do to the circuit, okay? It doesn't matter whether you increase or decrease the space between them, you increase or decrease the size of the plate or so on. Okay, as long as you're still using the same capacitor, then the final amounts of charge on each plate, it should be equal to the initial amounts of charge. All right, so for the previous questions, I'm going to add a note right here to represent it is an initial value. Okay, initial value. So now I'm going to look at final. So final amounts of charge on each plate, Q is equals to Q naught, which is equals to 9.6 times 10 to the power of negative 12 coulomb. Okay, why? Because battery disconnected. When battery disconnected, Q constant. Okay, Q constant. And also, okay, the questions also mentions that no loss of charge to the surrounding. Okay, so no battery, okay, no battery and no charge loss to the surrounding. So combining these two statements, we came into conclusions that Q is constant. Okay, Q is constant. Therefore, your Q final is equal to the Q initial. Then how about the potentials between the plate? Okay, now you are changing the distance between the plate, meaning that you need to calculate the new C. Okay, you need to calculate the new C. So C is still equals to epsilon naught A, but now you have a D new. Okay, you'll have a D new. So you increase it from 6 to 8. Okay, you increase the distance. The distance initially is, you increase from 2.5 mm to 8 mm. So you calculate the new separation, you calculate the new C, okay, and then you obtain a new capacitance. By applying same things, Q equals to CV, then you should obtain, oh, you want to calculate the potential, so Q equals to CV. No, I don't want this one, I want V. So V equals to, okay, V equals to what? V equals to Q over C. Okay, V equals to Q over C, which is then equals to 19.2 volt. Alright, so you plug in the value and you solve it by yourself. Okay, kamu sendiri kira. Tengok berapa nilai dia, and then kamu masukkan ke dalam equations. So V equals to Q over C, which is equals to 19.2 volt. The crucial point is battery is disconnected. Right, and then the capacitance of the capacitor. Okay, the capacitance of the capacitor. Well, basically now you have it already. You can just rewrite the answer. Okay, you can just rewrite it here. So your C, if you got it right, you should obtain 5.0 times 10 to the power of negative 13 farad. Right, done. So this question, the main thing is to test whether you understand these things or not. Okay, this part. No battery, Q constant. Okay, no battery, Q constant. So now I give you 1, 2, 3, 4 questions. I give you 3 minutes to write it down. Okay, saya bagi Anda 3 minit buat sedikit catatan. Manakah penting, manakah benar yang kamu kena ambil perhatian, and then you do the calculations. Okay, you do the calculations. Kamu sendiri kira tengok nilai dia berapa. So 3 minutes for you to write it down. If you have any questions, you may ask. Okay, so far so good. So the example 9, example 9, it combines both situations with and without battery. So let's see. Now, example 9, a vacuum parallel plate capacitor, it has an area. So now you have a vacuum parallel plate capacitor, has an area 150 cm. So once again, okay, you have cm squared. And the separation is 2 mm. So you look at the unit, you need to remind yourself, always change it to SI unit. And also the keywords right here is vacuum. So initially you have a vacuum parallel plate. So whenever you have a vacuum parallel plate, or they are being separated by a vacuum, by air, then that means you are going to look at epsilon naught, epsilon naught. Okay, so the permittivity of free space. The capacitor is charged to a potential difference V naught equals to 2000 volt. Then battery is disconnected. Aha. Battery is disconnected. Once again, this statement, it tells you Q final equals to Q initial equal to a constant value. Okay, so from the phrase itself, it is very important. Okay, it is very important. It tells you what happened after you remove the battery. And after you remove the battery, a dielectric sheets of the same area is placed in between the plate as shown in figure. Okay, so this is the typical dielectric questions, right? It tells you the initial conditions, and then after that, with or without battery. Okay, the questions will tell you with battery connected, you insert dielectric, or without battery, or the battery is disconnected, then you insert dielectric. So you look for the keywords. Okay, when it comes to the questions with dielectric, you look for the keywords. See whether there is or without. Okay, there is a with a battery or without battery in the questions. So in the presence of a dielectric, the potential difference now is being reduced to V equals to 500. This is your final V. Okay, so does it make sense? Yes, it does. Why? Because we say when we insert a dielectric into a capacitor, the net electric field drops. If net electric field drops, then V drops. Okay, so this is our dielectric. This is our capacitor. Initially, capacitor, it has an electric field from positive plate to negative plate. That is what we learned. And then we insert dielectric in between it. So now you have the plate. Okay, you still have the plate, positive, negative, with the same separations. You cannot change the separations here unless the questions mentions you change the separations. So now you have a dielectric in between them. So what happens right now is, okay, some of the electric field is being cancelled out by the dielectric. Why? Because of the dipole. Okay, so a dipole inside it is being arranged like this. Where now, okay, here is the negative dipole, here is the positive dipole. So some of the electric field is being cancelled out. So which means net electric field, okay, E net drop. Since we have E equals to V over D, D is constant, okay, D constant, because you are not changing the separations between them. So when E drop, V drops. So therefore, your final V is now 500 volt, which makes sense, okay, which makes sense. Initially 2000, after you insert dielectric, it drops to 500. So now let's look at questions A. Questions A asks you to calculate initial capacitance. Means that still without dielectric sheets. Okay, it's still vacuum. So if it's still vacuum, then you need to use all of the information for vacuum. So C naught equals to epsilon naught, okay, because you're still looking at vacuum. Okay, this is still at a vacuum. So epsilon naught A over D. Make sure everything is in SI unit. Plug it into the equations. Okay, you should obtain 6.63 times 10 to the power of negative 11 farad. Okay, that is the question. That's the answer for questions A. So C naught equals to epsilon naught. Remember, you're looking at vacuum. So epsilon should be from vacuum. Okay, should be for vacuum. And then questions B, the charge on each plate before dielectric is inserted. Okay, so you are looking at Q naught. Q naught equals to, well, Q naught, obviously you're going to use C naught and V naught. Okay, initial value. So plug in the value, you should obtain 1.33 times 10 to the power of -7 coulomb. Okay, -7 coulomb. So this one is before dielectric is inserted. Okay, next, it asks you to determine the value of capacitance after dielectric is inserted. How are we going to solve these questions? Well, first of all, let's see, do we have a final V? Yes, we do. Okay, so final V is equal to 500 volt. Do we have a final Q? Yes, we do. Why? Because the question tells us battery is disconnected. And when battery is disconnected, Q final equals to Q initial. So Q final equals to Q initial, which is equals to 1.33 times 10 to the power of -7 coulomb. So from here, we can then calculate C. Okay, so because you don't have the permittivity of dielectric, therefore you have to look for final V and final Q. So now I have C equals to Q over V. Plug in the value, I should obtain final capacitance 2.66 times 10 to the power of -10 farad. Okay, so now let's see whether my answer makes sense or not. So based on what we have learned in a lecture, we know that when you insert a dielectric into a capacitor, C should increase, right? So let's look at whether my C increase or decrease. So initially, I have 6.63 times 10 to the power of -11. After I insert dielectric, it becomes 10 to the power of -10. Obviously, my C increased with the presence of dielectric. So yes, my answer makes sense. Okay, my answer makes sense. If you calculate and you got a value that is smaller than your C naught, then it means there must be something wrong in your calculation. Right? So ini cara kita cek sama ada kita punya jawapan munasabah atau tidak. Okay, so macam mana cek? Kita tengok nilai C initial dengan C final. C initial tanpa dielectric. Tanpa dielectric dia punya nilai 6.63 kali 10 kuasa -11. Bila banding dengan after insert dielectric, kamu ada darab 10 kuasa -10, obviously kamu punya capacitance sekarang increase. So betul. Okay, sebab berdasarkan apa yang kita belajar, when you insert dielectric, then C increase. Okay, so it makes sense. So this one makes sense. So next one, the question asks us to calculate relative permittivity. So now you have a case with dielectric, insert dielectric when battery is disconnected. So let's see how are we going to calculate relative permittivity. Relative permittivity is epsilon. Okay, epsilon R. Okay, kita ada epsilon naught, epsilon. These two is the permittivity of dielectric. One in vacuum, one with a dielectric yang ada material. And then kita ada lagi epsilon R is just a ratio. So epsilon R, you have 4 equations. So you cannot use the one with epsilon because you don't have the permittivity of dielectric material. And then, well, you do have V. Okay, it's up to you whether you want to use a V or you want to use C. Okay, what we do know is epsilon R is equal to C over C naught or V naught over V. Okay, we have these 4 informations. So it's up to you which one you want to use. Okay, the final answer is just 4. Right? Terpulang pada Anda. Kamu nak guna equations yang C over C naught atau kamu nak guna V naught over V. Okay, sebab sekarang kita nak kira epsilon R when battery is disconnected. Okay, when battery is disconnected. So kalau battery connected, anda tak boleh guna V0 over V. Okay, kamu kena tahu ya, sebab kita sudah tengok dalam jam sebelum ini juga kan, we have seen it before. What is the difference with and without battery connected? So if battery is connected, then you cannot use V0 over V. Okay, you have to use Q0 over Q. But now because we throw the battery away, we disconnect the battery. So yes, we can use this one. Okay, we can use this part. So this one, it depends on whether battery is connected or not. If it is connected, then cannot use V0 over V. But now battery disconnected, then yes, this is all right. Okay, this is valid. So epsilon R, you have two equations that can be used. It's up to you which one you want to use. Okay. So if you are afraid that you make any mistake, okay, if you don't know whether you should use V0 over V or Q0 over Q, then you stick to the first one. Okay, you stick to this one. This one is always correct in any situations. So epsilon R equals to C over C0 equals to 4. Okay, equals to 4. Next question asks you to calculate the permittivity of dielectric material. Okay, dielectric material. So how are we going to calculate it? Well, we know epsilon R, it is also equals to epsilon over epsilon naught. All right, so rearrange the equation. Epsilon is equals to epsilon R epsilon naught. So it is equals to 3.55 times 10 to the power of negative 11. Now, this one is not dimensionless. It comes with dimension. C square n negative 1 m negative 2. If, okay, in the exam, usually students, they will tell me, Miss, I don't know what is the unit for epsilon. You look at the list of constant. Okay, epsilon and epsilon naught, both of these, they have same unit, which is c square n negative 1 m negative 2, and it can be found, okay, can be found in the list of constant. So you don't have to memorize the unit. Okay, you can check the list of constant, you search for the unit. Okay, kamu cari epsilon naught. Sebab epsilon naught diberi dalam list of constant. So dari epsilon naught punya unit, kamu tahulah ini adalah unit untuk epsilon. Alright? So whereas for epsilon R, this is no unit, dimensionless quantity. Okay, dimensionless quantity. That's why in questions D, I leave it as 4. But in questions E, I write down a unit, C square, n negative 1, m negative 2. Okay? So questions F. Okay, initial electric field. So initial electric field, you calculate it by using initial potential difference. Okay, initial potential difference. So E naught equals to V naught over D. Okay, you use V naught, initial potential difference. So it is equals to 1 times 10 to the power of 6 volt m negative 1 volt per meter. Okay, volt per meter. And the last questions, after dielectric is inserted, then you use final V. Okay, so E equals to V over D, which is equals to 2.49 times 10 to the power of 5 Vm negative 1. Now, of course, if you want to use, okay, or if you want to use epsilon R, also can, because we know when battery is disconnected, epsilon R at the same time, it is also equals to E over E naught. Okay, so again, this one is when battery is disconnected. Okay, battery is disconnected. So epsilon R equals to E naught over E. So rearrange the equations. E is equals to 2.49 times 10 to the power of 5 Vm negative 1. So the things that you have to remember is when you apply V naught over V and you would apply E naught over E, the condition is disconnected. Kalau battery connected, then dua equations ini dia sudah tak valid. All right, they are invalid. Okay, so done. Okay, we are done with all 9 examples in chapter 2. So that marks the end of chapter 2.